Good morning children. In today's class we are proceeding with exercise 7.1 problems based on matrices. Question number 5. If A equals 1A01, find A power 4. Let us calculate what is A square, which is A into A. 1A01 into 1A01. Remember, row by column. Row by column. 1 into 1 plus A into 0. First row by second column. 1 into A plus A into 1. Second row by first column. 0 into 1, 1 into 0. Both are 0 only. 0 into A, 1 into 1. As we simplify, we get 1, 2A, 0, 1. Our question is to find A power 4, which is A square into A square. What is A square actually? 1, 2A, 0, 1 into 1, 2A, 0, 1. As we multiply, again row by column. 1 into 1 plus 2A into 0. 1 into 2A plus 2A into 1. 0 into 1 plus 1 into 0. 0 into 2A plus 1 into 1. So what is our answer? A power 4 is 1, 4A, 0, 1. Question number 6. A alpha is cos alpha minus sin alpha, cos alpha. Show that A alpha, A beta equals A alpha plus beta. If alpha comes here everywhere, alpha we have written. If I want A beta, wherever alpha comes, let us replace beta. My question is to multiply. How to multiply? First row by first column. Cos alpha, cos beta into minus sin alpha, sin beta. As I multiply, first row by first column. Now, first row by second column. Cos alpha minus sin beta minus sin alpha cos beta. First row by first column, first row by second column is done. Now, second row by first column. Sin alpha cos beta, cos alpha sin beta. Second row by second column. Sin alpha minus sin beta. Put minus in the beginning. So it is sin alpha sin beta with negative symbol plus cos alpha cos beta. As we recall trigonometry formula, cos A cos B minus sin A sin B pattern, it is cos alpha plus beta. Here I take minus sign out. It becomes minus of sin alpha cos beta plus cos alpha sin beta, which is sin alpha plus beta. After taking minus out, it becomes sin alpha plus beta. Here, sin alpha cos beta plus cos alpha sin beta is sin alpha plus beta. Cos alpha cos beta minus sin alpha sin beta reduces as cos alpha plus beta. We check these two are one and the same. These two are same, but the symbol alone changes. As I compare the question and this, wherever alpha comes, now alpha plus beta is coming. So I can call it as A alpha plus beta, and that is the RHS. We started with LHS. We have arrived at the RHS. Second subdivision, show that A alpha plus A alpha transpose equals I. Let us write A alpha transpose. It is interchanging rows and columns, cos alpha, sin alpha, minus sin alpha, cos alpha. As we add, A alpha plus A alpha transpose is, we get cos alpha plus cos alpha 2 cos alpha minus sin alpha plus sin alpha 0, sin alpha minus sin alpha 0, cos alpha plus cos alpha 2 cos alpha. What is given actually in the question? Given A alpha plus A alpha transpose is I. As we compare the answer with I is unit matrix 1001. Corresponding entries are equal. We get 2 cos alpha is 1 or cos alpha is 1 by 2. Let us recall from trigonometry. Cos equals half tells us principal value pi by 3. The general solution we call theta equals 2 pi n plus r minus principal value. In this question, instead of theta, we have alpha. Principal value is pi by 3. So the answer is alpha equals 2 pi n plus r minus pi by 3. Question number 7. If A equals 4 minus 1x and A minus 2i into A minus 3i equals to 0, find x. A minus 2i. A value 4 minus 1x. What is minus 2i? Minus 2 into I is 1001. That is 4 minus 1x plus multiply minus 2 in minus 2 0 minus 2. As we add corresponding entries, 4 minus 2 2, 2 plus 0 2, minus 1 plus 0 minus 1, x minus 2 as it is. Let us find out A minus 3i in the same way. As we add corresponding entries, 4 minus 3 1, 2 plus 0 2, minus 1 plus 0 minus 1, x minus 3. Now the question is A minus 2i into A minus 3i equals to 0. That is, as we multiply 2 minus 1 x minus 2 into 2 minus 1 x minus 3 equals to 0 tells me all the entries are 0. As we multiply row by column, 2 into 1, 2 into minus 1. First row by second column, 2 into 2, 2 into x, 2x, 2 into minus 3, minus 6. Second row by first column, minus 1 into 1, minus 1, minus 1 into x, minus 1 into minus 2. Then second row by second column, minus 1 into 2 plus x minus 2 into x minus 3. This is equal to 0, 0, 0, 0. Let us compare an easy entry, say the first one. 4 minus 6 plus 2x equal to 0. Or I can compare this also. Any of these entries I can compare. So let me compare these two. I get minus 1 minus x plus 2 0 or minus x plus 1 0 or minus x is minus 1. We get x is equal to 1 and that is the answer. Question number 8. If A equals 1 0 0 0 1 0 AB minus 1. Show that A square is a unit matrix. A square tells us A into A. What is A given? 1 0 0 0 1 0 AB minus 1. Let us multiply again the same matrix. Remember how to multiply. It is row by column. 10010A. For clarity, we have written first row by first column, first row by second column, first row by third column. In the same way, second row by first column, second by second, second by third, third by first, third by second, third by third. In the beginning, one problem we can list out like this, but it is good that you know to write directly. As I multiply, first and first, second and second, third and third. 1 into 1, 1. 0 into 0, 0 into A. 1 into 0, 0 into 1, 0 into B. 1 into 0, 0 into 0, 0 into minus 1. 0 into 1, 1 into 0, 0 into A. 0 into 0, 1 into 1, 0 into B. 0 into 0, 1 into 0, 0 into minus 1. A into 1, B into 0, minus 1 into A. A into 0, B into 1, minus 1 into B. A into 0, B into 0, minus 1 into minus 1. As we simplify, we can check. It is 1, 0, 0, 0, 1, 0, and the last row 0, 0, 1, which is nothing but I, and hence we have shown A square is a unit matrix, and hence the problem. Question number 9. Given A matrix, we need to find K with a relation A cube minus 6A square plus 7A plus Ki equals 0. How to find A cube? First step is to find A square. A cube will be A square into A. Try it yourself and check your answer. As we calculate A square and A cube, let us substitute in the relation. A cube, the answer 21, 0, 34, 12, 8, 23, 34, 0, 55. A square, we need to multiply by minus 6. Every number multiply by minus 6. So we put plus minus 6 into 5, minus 6 into 0, minus 6 into 8. 2 into minus 6, 4 into minus 6, 5 into minus 6, 8 into minus 6, 0 into minus 6, 13 into minus 6. I need 7A. So this is A matrix. Multiply each number by 7. 7 ones are 0, 2 sevens are 0, 2 sevens are 1 into 7, 2 into 7, 0, 3 into 7. What is I? I is unit matrix. Remember, it is 3 rows and 3 columns. I want Ki. So multiply each entry by K. I get K0, 0, 0K0, 0, 0K, and the RHS is 0. Let us add the corresponding entries. 21 minus 30 plus 7 plus K. Second entry is 0. Third entry is 34 minus 48 plus 14 plus 0. Second row 12 minus 12 plus 0 plus 0. 8 minus 24 plus 14 plus K. Third entry 23, 37 plus 0. Third row 34 minus 48 plus 14 plus 0. All the second entry is 0, 0, 0, 0. So just put 0. Third entry is 55 minus 78 plus 21 plus k, and this is equal to 0. As I simplify, 28 minus 30 minus 2 plus k, 0, 0, 0 minus 2 plus k, 0, 0, 0 minus 2 plus k. The entire thing tells us 0, tells me every entry 0 in the matrix. Let us compare the corresponding entries. As I compare the corresponding entries, I get k minus 2, 0 or k equals 2. Hence the problem. Question number 10. Give your own examples for matrices A and B such that AB not equal to BA. Case 1. AB and BA are 0 where A and B are not equal to 0. Case 2. Case 3. AB is 0 where BA is not equal to 0. First one is a simple problem. For most of the matrices, AB is not equal to BA. Let us give an example. Capital A we have assumed as 1023. B is 0145. As we multiply and check, our answer is 011217. BA. B first and then A. As we multiply, we check both are not equal. AB and BA are not equal. Second subdivision, both the matrices become 0. The product AB as well as BA. How are we to frame A and B? If I keep first row to be 0 here, let me keep second row to be 0 here. If I keep second column to be 0 here, keep first column to be 0 here. A technique to remember, when I multiply naturally, first row by first column 0. So my answer is 0. First row by second column also gives me 0. Same way, second row itself 0. So multiplying gives me only 0. BA. First row 0. Multiplying both the columns I get 0. Here, second row by first column again 0. Second row by second column again 0. You have a problem where AB is 0 but BA is not 0. How to frame it? Here alone I have kept zeros. Here I have kept any two elements. As I multiply, I check. Here all the three are zeros. Here first element is non-zero. Keep the first element 0 here. So that when I multiply, I naturally get 0. BA. If I reverse, here two elements are there. So naturally one element I will get. So it is not 0. So we have shown AB is 0 whereas BA is not equal to 0. Question number 11. Show that f of x into f of y is f of x plus y, where f of x is given like this. If f of x is this matrix, how to write f of y? Wherever x is coming, we shall replace y. Zeros and ones we will copy as it is. How do we multiply? First row by first column. So cos x cos y minus sin x sin y. Third one 0 into 0. Similarly, first row by second column minus sin y into cos x. Minus sin x into cos y. 0 into 0. First row by third column 0 into anything, 0 into anything, 0 into anything. It is 0 only. Second row by first column. Sin x cos y, cos x sin y, 0 into 0. Second row by second column, sin x into minus sin y, cos x into cos y, 0 into 0. Second row by third column, 0 into 0 into 0 into. All the entries are 0 only. Third row, 0 into 0 into 0 into 1. So, here again 0. Third row by second column, 0 into 0 into 1 into 0. So, all the entries are 0. Again, third row by third column, 0 into 0 into 1 into 1, 1. As we simplify, it is again the trigonometry formula cos x cos y minus sin x sin y becoming cos x plus y. If I take minus sign out, it is sin x cos y plus cos x sin y, that is sin of x plus y. The third entry 0. Here sin x cos y plus cos x sin y is sin of x plus y. Again cos x cos y minus sin x sin y. Both are same. It is cos x plus y. Third entry 0. Third row 0, 0, 1. And I can check. Wherever x comes in the question, I have x plus y coming. So f of x is now becoming f of x plus y. The same matrix is followed here, but x becomes x plus y everywhere. So f of x will now become f of x plus y. So we have proved that f of x into f of y equals f of x plus y, and hence the problem. Question number 12. If A is a square matrix such that A square equals A, find 7A minus I plus A the whole cube. As I expand using A plus B the whole cube formula, I plus A the whole cube. Wherever A comes I, wherever B comes A. As I substitute, it is I cube plus 3I square into A plus 3I into A square plus A cube. 7A minus, I know I cube is I only. I power any number because I is unit matrix. So remember, I is unit matrix. Whatever be the power, I is I only. Now, I square is also I only. So I into A plus 3. I into A square is only A square. A cube I can write A square into A. Wherever A square is coming, I can put A. Substituting 7A minus I plus I into A. So remember, I into A is A only. So 3 into I into A is simply 3A. 3 into, in the place of A square, I have to put A. In the place of A square, I have to put A. The next step, 7A minus I plus 3A plus 3A, I can combine and write 6A. Plus A into A is A square. A square is again A. As we simplify, 7A minus I minus 6A minus A. 7A and these getting cancelled, giving us only minus I. So it's an important problem to understand I raised to any natural number. I will say it is I only. I into any matrix gives us only that same matrix. So having this idea, we can deduce the problem. Wherever A square is coming, let us put A and we will arrive at the answer. Question number 13, verify the property A into B plus C equals AB plus AC given the three matrices as in the question. How shall we verify this? There are 5 steps. Find out B plus C, find out A into B plus C, that is LHS. Find out AB, find out AC and then add it, that is RHS. Show LHS equals RHS. Try it yourself and check your answer. B plus C, as we add corresponding entries, A into B plus C, first row by first column, first row by second column, second by first, second by second. That answer we shall mark as number 1. Proceeding to RHS, we'll find out AB. A into B, again row by column. We have multiplied. AC, row by column, we have multiplied. Adding AB and AC, we have verified. 1 and 2 are equal, implying A into B plus C equals A into B plus A into C, and hence the problem.